A common way to express concentration in chemistry is known as molarity. And molarity is symbolized by capital letter M, and often the concentration of a solute is expressed in brackets, and that means we're talking about its molarity. So molarity is how many moles of solute are in 1 liter of solution. And sometimes if we're dealing with smaller amounts, we can use millimolar or micromolar or nanomolar, but in this class we're just going to focus on molarity. So here it is, the definition of molarity. It's the chemical amount of solute in units of moles divided by liters of solution, not milliliters of solution, liters of solution. So let's look at determining molarity for a given solution. Determine the molarity of a solution prepared by dissolving 5 grams of potassium iodide, or Ki, in water for a final solution volume of 0.125 liters. So how do we solve that? Well, to solve for molarity, we need moles of solute and we need liters of solution. We're given the liters of solution, 0.125, but we're not given moles of solute. However, we are given the mass of solute in grams. And we remember that we can convert between mass and mole, and to get from mass to mole, we divide the mass by the molar mass. So we have to calculate the molar mass by looking at the periodic table. And the molar mass of potassium is 39.10 grams per mole, and that of iodine is 126.90 grams per mole. So when we add those together, we get 1 mole of potassium iodide is 166 grams of potassium iodide. So we take the 5 grams of potassium iodide, we divide it by the molar mass, and we end up with 0.0301 moles. And that makes sense because we have 5 grams, which is way less than 166 grams. So I should have way less moles than 1. Excuse me. So then we simply plug into the formula. 0.0301 moles divided by 0.125 liters is equal to 0.241 moles per liter.